if your high-speed network goes down, the culprit usually isn't, a massive server failure. It's often just a microscopic shift in a piece of glass that's actually thinner than a human hair. Welcome to today's deep dive.
Yeah, it's crazy to think about.
Right. So our mission today is to examine a very specific product listing from HDTV Supply. We're looking at the Avenview FO-MMS-LC-LC-75 fiber optic patch cable.
It is quite a dense spec sheet, I have to say.
Oh, for sure. But we're going to extract the core insights on why this exact piece of hardware is just so critical for high-speed, high-density setups. Okay, let's unpack this, because it is incredibly easy for you to just take for granted that we are pushing 10 gigabits over a 75-meter run.
Yeah, that is 246 feet.
Exactly. But when you look at the microscopic precision required to make that possible without dropping a single packet, I mean, it is absolute engineering magic.
It really is. Anyone working in IT knows that scaling up to 10 gigabit speeds means the margin for error essentially just vanishes.
Poof, gone.
Right. We aren't just talking about blasting light down a tube anymore. We are talking about highly controlled photonics.
Which brings us perfectly to the specs of the glass itself. So this is a 10 gigabit OM3 Aqua multimode simplex LC to LC cable. It features a 50 micrometer core surrounded by 125 micrometer cladding.
Right, the glass layers.
Yeah. And instead of that old cliche of a data superhighway, think of this like a microscopic superhighway, where the 50 micron core is the fast lane specifically optimized for laser light.
Mm-hmm.
Or imagine yelling down a perfectly mirrored hallway.
Oh, that's a good analogy.
Thanks. Because if the hallway isn't tuned perfectly, the echoes of your voice bounce around, they smear together, and the person at the other end just hears, well, noise. This 50-micron core is tuned so specifically that the echoes of the light pulses don't smear together and ruin the signal.
Yeah, and what's fascinating here is how deliberate that engineering is, especially when you look at the OM3 designation.
Right, because older cables, the OM1 or OM2 ones, they relied on standard LED light sources, didn't they?
Exactly. But this OM3 cable is laser optimized for VCSEs.
Wait, VCSEL?
Yeah, vertical cavity surface emitting lasers.
Ah.
VCSELs fire incredibly fast, tightly focused laser pulses. By optimizing the glass specifically for those frequencies, this cable eliminates that signal smearing, what we call modal dispersion, allowing it to maintain that 10 gigabit bandwidth over the full 75 meters.
Wow. But to keep that laser light perfectly contained, the glass is really only part of the equation, right?
Right.
Because the real failure point is where that glass actually meets your server. And here's where it gets really interesting, because high speeds require extreme physical precision at the connection points.
Absolutely.
This cable uses push and pull LC connectors, which are, what, half the size of older SC connectors?
Yeah, half the size, making them ideal for cramped high-density server racks.
Right. But the spec sheet heavily highlights that they use ceramic ferrules inside those connectors.
Yeah.
And I have to push back here. Wait, ceramic?
I know, it sounds weird.
We're talking about high-speed data networks, not pottery. Why on earth are we using ceramic for a tiny cable connector instead of, I don't know, high-grade plastic or metal?
Well, you would definitely care about that ceramic the moment your server room's air conditioning fluctuates.
Oh, because of the heat.
Exactly. Metal expands and contracts with heat. Plastic warps over time. When you are dealing with a 50-micron core, if the connection shifts by a fraction of a hair due to temperature changes in the rack, your laser alignment is just ruined.
That makes total sense.
Ceramic is thermally stable. It ensures exacting, long-lasting precision alignment regardless of the environmental heat. Furthermore, the cable features an OFNR jacket.
Which stands for optical fiber non-conductive riser, right?
Spot on, meaning it's strictly fire-rated to run vertically between building floors without, acting as a fuse during a fire.
So you have a fire-safe, thermally stable, micro-precision glass hallway. That logically brings us to the cost. It's priced at $147.93 and comes with a 3-year Avenview warranty. Considering the engineering we are talking about, that actually seems incredibly accessible.
It is. And if we connect this to the bigger picture, the true economic benefit goes far beyond just the retail price of the cable.
Oh, for sure.
The crucial detail for anyone designing a network is that this is a pre-terminated solution.
Right, because terminating fiber optic cables in the field isn't like just crimping a copper Ethernet wire.
Not at all. It requires microscopic polishing, specialized epoxy, and, well, highly paid fiber technicians to manually align those ceramic connectors.
That sounds expensive.
It is. Because this arrives pre-terminated from the factory, it completely eliminates that specialized labor time, leading to a drastically lower installed cost.
So what does this all mean? This isn't just a simple wire you plug into a wall. It is a precision-engineered, cost-saving bridge designed to handle the zero-tolerance environment of high-density telecommunication networks.
Precisely. It basically takes the most volatile variables of networking human error during installation and thermal expansion in the server rack and engineers them out of the equation entirely.
Which leaves you with a final thought to mull over. If a 246-foot thread of glass can flawlessly carry 10 gigabits of data using microscopic lasers today, what physical limitations of our buildings will need to fundamentally change when the devices at either end demand even more bandwidth than these current optical highways can support?